Welcome to the Bounty Zero X podcast. I'm your host, Angelo Adam, founder and CEO of Bounty Zero X. Bounty Zero X is a decentralized bounty hunting network powered by the BNTY token. My guest on the show is Arjun Optani. Arjun is CEO of Connext.network. Arjun, welcome to the podcast.
Thanks a lot, Angelo. Thanks for having me.
Yeah, my pleasure. So, Connext is a free open source P2P micropayment infrastructure built using payment channels on Ethereum blockchain. Can you give us a brief introduction on what you guys are solving and your product?
Yeah, absolutely. So one of the sort of like purported benefits of blockchain from early on, or of like Bitcoin from early on, was like the ability to do internet micropayments, right? The ability to have content creators be paid very small amounts of money for their content, or like micro fees going towards paying for developer help, or machine-to-machine payments where your solar panel is paying your electricity provider a very, very small amount of money. Unfortunately, a lot of those things didn't pan out because Bitcoin and in general, like a lot of the proof of work blockchains, were kind of an incomplete solution for this specific activity. So on Bitcoin, as a result of that, as a solution to that, people built the Lightning Network. Connext is something really similar. We're building payment channel infrastructure on top of Ethereum. The goal is to have this eventually be a full network where anybody who's connected to the network can pay anyone else who's connected to the network for very, very low cost. Right now, we have a subset of that network available for use for everybody, and what that does is allow you to pay at very low cost to anybody who's connected to a single node. Now we say that this is great for micropayments because one of the way that payment channels works is that you have to sort of it's like a debit card. You put in some money and then you pay directly from that. And I think until people are willing to put, it seems to be the most prominent use case.
Yeah. So what amount of money needs to be put in order to open a channel? And are channels one-to-one with one individual person, or can they be one channel to multiple people?
Yeah, that's a good question. So we've sort of like okay. So I'll answer the first question first. So right now channels are kind of expensive. The way that they work is that they're no longer just like a channel. It's a channel wallet. You don't just sort of open and close them anymore. You deposit and withdraw from them like you would with a normal wallet, and everything else is handled in the background. And your channel sort of always exists. So like even if you withdraw all of your funds from it, people can still send to you at that address. Because we've turned it into this like more complex construction, depositing into a channel is actually more expensive right now. I think it costs $4 on mainnet, which is in my opinion way too expensive. We haven't really done any gas optimizations in the contract, so I expect to reduce that down at least to like 25% of what it is right now when we actually do get a chance to do those changes. As for how the channels work, channels are basically created like there's one counterparty, which is the user, and then the other counterparty is always the hub or the node. The hub is basically an automated actor. It's a daemon that just sort of anyone can run that looks a lot like a Lightning Network node, where anybody who is connected to that node can pay anyone else who is connected to that node. So what happens is you, Angela, if for instance I'm paying you, I would pay the node and the node would pay you. And then there's a bunch of fancy cryptography that happens in the background to make sure that the transaction payload is relayed correctly and that the node isn't actually interrupting the transaction.
So in theory, it's possible to have multiple people connected to a node and sending payments to other people?
Yep, and I think that's actually the biggest benefit is that I can put $10 into my channel. I can pay you $1, and then I can also pay there could be 10,000, 100,000 people connected to the same node if or more. I mean there's really technically no limitation other than the amount of collateral that people put in. So I could then pay any of those other people without having to do another on-chain transaction, which is pretty wonderful.
Yeah. So, but each person needs to open up a channel in order to connect to it.
All of these senders do.
Oh, so, but a receiver doesn't need to open a channel to connect to the node.
Technically not. Now we do have like a security mechanism in place where the receiver has to quote unquote authorize, which just means that they have to actually claim the address so that the hub knows that this isn't just a spam transaction. But no, there's nothing that other than that, there's nothing really that the receiver would need to do.
And one of the features is that coincides with that is that withdrawals from the channel are free. So let's say in an example use case, you have a blog, a micropayments blog, where people post articles and they receive small tips for creating content or reading content. Once you receive that tip, you can then withdraw gas free from the wallet that you received that tip from, and then send it to another wallet without paying a transaction cost or transaction fee for that.
Yes, so long as that other wallet was also connected to the same hub. For now. So the gas fee transactions happen when everyone is connected to the same hub. Now you can withdraw, and we have it sort of pre-configured where when you withdraw, and that sort of completely exits the system. We have it pre-configured so that when you withdraw and you withdraw to your MetaMask or your Trust Wallet or anything else, the hub pays the gas for that right now. That's a tunable parameter, and I expect that different projects will have different needs there. So I don't expect that everybody will do that.
So how are non-custodial versus custodial hubs defined?
That's a great question. So the cool thing about payment channels is that anything that you put in there is always not, like the funds that you have in there are always non-custodial. So when I say like a custodial hub versus a non-custodial hub, if I put like $100 into my channel, that $100 is always mine. As long as I have the state for that $100, I can always reclaim it on chain. Now, what I mean by so in that sense, it's always non-custodial. Now, what we mean when we say custodial versus non-custodial payments is that the transaction itself may be custodial. So if I pay you $1 through the hub, there's two ways to do it. One would be I pay the hub $1, and then the hub pays you the dollar, and then the hub that while we're waiting for the hub to do the second half of that transaction, the transaction itself is custodial because the hub could choose not to relay that $1 and then steal my $1. Now, of course, if they did that, I could just leave with my other $99. So your risk is kind of small there, relatively speaking, but that is still a trusted payment. A fully non-custodial hub, which is code that we have working right now, but hasn't always been implemented everywhere, just because it's a little bit more complex, is where I send the hub a transaction, but while I send the hub a transaction, I also send you an update saying, like a promise saying that I've sent the hub a transaction. And then if the hub doesn't do the second half of the payment, you can then put that update on chain and claim $1 from the hub's $1 from the channel, from the hub side of the channel. Does that make sense? So it's kind of like a doing a dispute in the existing payments world.
Yeah. And so in that case, the hub would then be required to pay the second half of the transaction, even though the original sender never sent it.
No, the original sender would have to send it. So what would happen is if we wanted to dispute this $1 transaction, you and I would both go on chain, or you as the receiver would go on chain and show that I had made this commitment to pay you, and I had also theoretically made this commitment to pay the hub, which I could or could not have done, but you don't necessarily need to know that. You could put that state on chain and get your $1 from the hub. And then the hub can then now has an incentive to then come to me and say, okay, well, if I hadn't paid the hub, they can come to me and say, well, I still need this $1 from you. And if I refuse to pay it, then the hub can do exactly the same thing. They can put that the state that represents that $1 on chain, and then actually force the contract to give me the dollar, give them the dollar. Sorry. Does that make sense?
Yeah, that makes sense. I read an example or an explanation of how the security of the payment channels is set up in that um, it relies each party to go on chain and uses a smart contract to adjudicate and rectify disputes. So that was in the blog post that one of your colleagues wrote on your blog.
Mm-hmm.
Lets two parties behave as though they're transacting on chain, even though they aren't, because they have the ability to go on chain at any time as the balance updates that they send back and forth carry the weight of on-chain transactions. Dispute the contract simply decides whose balance is more recent by pulling the mainnet chain. So it's
Yep.
it's like an off-chain ledger that is then settled on-chain.
Yep, exactly.
Um,
Exactly. And like what we found is that in the vast majority of cases, people will not cheat because they know that even if they could cheat, they wouldn't really get away with it, and they just pay like an additional additional gas fees in order to settle the dispute. But it ends up being in like, again, in the majority of cases, this ends up being a very secure paradigm.
Mm-hmm. So you mentioned earlier Lightning on Bitcoin as an example of a state channel implementation. And how, I guess on a high level, a generalized level, what are some of the similarities and differences between the Lightning implementation and the Ethereum state channel implementation that you guys have developed? I guess it's basically it's doing the same thing, but what are some of the similarities and differences?
Yeah, absolutely. So the similarities are that we were like very heavily inspired by Lightning's architecture. I think in general, all payment channels are inspired by the way that like payment channel networks are inspired by the way that Lightning has been implemented. There's a lot of similarities in the way that we do multi-hop transactions. A lot of the core assumptions are the same, where I pay somebody and then they pay somebody and then they pay somebody and then that person pays the recipient. There's a few differences right now, and then there's a few differences which will always exist. The few differences right now are that for now what we have available is we sort of Lightning and then Raiden have sort of focused more on the building the entire network and like having that network architecture be available. We took a slightly different approach where we wanted to make the core technology usable for like actual commercial applications first, while we did research on and like finished building out the rest of the network. It's like a slightly different approach. Like it's just validating different assumptions at different times. And because of the fact that Lightning and like now Raiden have spent the time building the network first, we felt kind of secure that we could rely on the networking being sort of the same. So it's kind of just we're taking advantage of the open source knowledge that they've generated. In the next year, our goal is to be in that, like to go in that direction and to have a multi-hop implementation done. And so what I want is for Connext to look like that within a year, obviously with some caveats. So that's the ways in which we're similar. The ways in which we're different, Lightning uses something called HTLCs, which are hash time lock contracts. Basically, what happens is users send a payment that is locked, and you send a secret to the recipient. And then once that locked payment gets to the recipient, the recipient unlocks it with the secret, and then sort of passes that secret back so that everyone can then subsequently unlock the payment. It's like similar to what we do, except it's different in like one core way. Ours is more like dispute based, where in the optimal sort of happy case situation, there's a lot less work, and then in the bad situation where there's a problem, there's a little bit more work. So that's like one of the trade-offs that we've made. The other major difference is that because of the fact that we're not using hash locks, we have the ability to really easily implement more arbitrary conditional payments. So we can like do a payment and then have it resolved based on something that happens on chain. So I could pay you to calculate a zero knowledge proof for me. You could put that proof on chain, and then you would only be able to redeem the payment if you could prove that that happened on chain. So that's like another. We found that there's like a subset of use cases related to asynchronous payments that are still programmable and still need to be trust minimized that weren't really served by the existing Lightning type paradigm of like, both like the party needs to be online in order to pay.
What are some of those use cases for asynchronous payments where the party's not online? Like what would be like a commercial application of that type of use?
Yeah, good question. So I think the places where Lightning is really great, and like synchronous payments, which we have available right now, are really great, are places where like both like one or both parties are online. So like if I'm watching a video stream and paying like once every 20 seconds to like micro paying like 1 cent every 20 seconds or something like that to watch a stream. That's a great example of something that you can do now very, very well. It's also very good for like a single payment where like I go to a grocery store and I buy $2 worth of stuff and I just like pay and then leave. It's the latter, which is conditional payments and asynchronous payments, are good for things like marketplaces where I pay for some computation on Golem, and then I don't want to stick around and wait for that computation to be done, but I do also don't want my payment to succeed if the person says they're going to do the computation but then doesn't do it. So it's like in situations where you're not really like live and around. And what we found is that tends to be the case for more peer-to-peer marketplaces rather than content, or rather than just pure machine-to-machine payments. If that makes sense.
Yeah, that makes sense. So you mentioned a minute. You alluded to your roadmap over the next year or so, focusing more on the networking side rather than the commercial side. So what else is? What are some other roadmap plans that you have over the next, I guess, 1 month to mid to long term?
Yep. So there's a couple of things that a couple of assumptions that we want to validate right now. A big one that we're trying to figure out is to figure out how better to allocate collateral within hubs. Right now, the incentive to run a hub is like there's still an incentive if you're an existing organization that wants to provide payments to your users. But aside from that, it's the incentive to run a hub is actually low for the average person because the cost of like financing collateral for it is still high. We want to find we're interested in finding really good ways to scale our own understanding of that, and I can come back to that in a second. The other things that we're really interested in like proving out before we start on the next step of like building the network is figuring out what sorts of other issues there are around payments that we just don't fully understand yet. So like there's a whole category of unknown unknowns. Asynchronous payments, conditional payments was one of them where we weren't really sure if there was a lot of value in that. And then recently we spoke to a bunch of projects that were like, no, we would really need that in order to function at all. And so now we understand why those need to exist. Now, from a more material standpoint, what we're doing right now is we just launched, or we're just in the process of launching card.connext.network. That's a very basic, like a channel implementation that uses a hub that we ourselves are hosting. That's DAI Maximalist. the goal with this is it kind of looks like the burner wallet. It kind of looks like, Spank Chain, Spank Card. That's actually where we got our influence from. The goal with it is just to give people a very easy way to start using channels and not have to think about it. And so you could actually check that out today. It's available on Rinkeby. We put it up there a couple of days ago, and then we're planning on putting it on mainnet within the next couple of days as well. The secondary goal is to that's the primary goal, and that's actually how we're collecting data on collateralization. Is we're just going to run a hub ourselves, and eat the cost, and then at some point we will figure out how to reduce that cost, because we'll be very incentivized to do so. The secondary thing that we're interested in doing right now is integrating with as many projects as possible. So projects that need to do payments to their users with in a way that's very low friction, in a way that doesn't cost a lot of money, and either where they're using our hosted hub or where they're spinning up their own hub, because I think in both cases we can learn a lot.
Yeah, we'll include a link to the Connext network, and that supports. So you recently announced that you're going to be supporting the DAI ERC20 token, and that's in the card page and the card wallet or
Yes.
the card hub.
Mm-hmm. Yep.
But in theory, any ERC20 token can be used in a hub, but this is just one of the hubs that you built with support for DAI.
Yes.
As a use case, as a proof of concept.
Yep, exactly. The way that sort of hubs work right now, and this is definitely something that we plan on changing. But from a security standpoint, we limited hubs to 1 token in ETH for now. We tried spinning up a hub earlier where with Spank Chain, in October, where a user could input any token and transact in any token, and that was really cool. But the problem is that that opens up a set of attack vectors related to users creating malicious tokens, where the token contract itself does something different than what we expect. And so what we wanted to do was we wanted to shut off all of those potential attack vectors for now while we figure out the rest of the technology, and then come back to that when we find that there are enough people that want to create hubs with multiple different tokens.
So yeah, that makes sense. So let's see, where do I want to just changing topics and going to an example use case of we have added to our Telegram channel the par jar. It's a bot that allows easy tipping, and our users have been very positive in their support for that type of product. They're really excited and they use it quite frequently. So it just shows, I think, the potential for that type of use case. And I don't think they're doing state channels implementation. Are you familiar with that and how that works?
I'm not, but I definitely want to check it out. It seems really interesting.
Okay. So tell me what some of the metrics over the next 12 months. You talked about some of the assumptions you're going to be working on. What would be a metric for success over the next few months or 12 months that you think would be some accomplishments that you guys would be happy if you guys completed?
I think there's two. One is so in the short to middle term. So within the next few months, I think a metric that we're really interested in tracking is the amount of funds locked up in the hub by users, and in all of our hubs across all of the hubs that are being run by users. I think that's a pretty interesting metric because it's kind of a proxy for transaction volume. It's kind of a proxy for the sort of the use of the hub itself. we can track more in-depth metrics, which are number of transactions done and like actual transaction volume per payment. But the metric that I mentioned, which is just the amount of funds locked up, is something that's publicly available. So like tracking that would just be a matter of checking on chain on each contract to see how much what the value of the contract is, minus what the value of the hub, the value that the hub is holding. The latter two things are things that we'd have to actually go and talk to hubs, get their database logs, and like query their databases for actual for their own metrics, which sometimes in some cases will have issues with privacy. So we're still sort of iffy on that. Long term, I think, or slightly longer term, I think what we'd want to focus on is the number of nodes / hubs we have up. The only distinction there is that hubs are we're calling them hubs while they're not all connected to each other, but the moment that they are, the goal is they would be nodes in the network. And at that point, I think the number of nodes in the network is definitely a very, very valuable metric for us to keep track of.
Okay. This is a side note. I was on Twitter reading someone who tweeted about how there's a lot of excitement about Lightning, but that if for people who think that Lightning is this scaling solution that will solve all of the problems that Bitcoin is facing, they're not being very realistic. And I think they listed a couple reasons why that is the case. And I think one of the reasons they said was that it's not practical to expect people to fund these state channels just to receive like a small micropayment. I think I'm not really doing the quote justice because I don't remember exactly what it was saying, like the specific, but it was something along those lines, like a comment that it didn't make sense for users to have to, invest like a sum of money in order to maybe, get back this or to pay the cost up front to create the channel.
Liquidity, and then
Yeah, I think that was. So is there like how much is the amount of money that needs to be funded into a channel proportional to, I guess, the like the number of transactions that are going to be going through that channel? So so how is that calculated? Like how much funds need to be
locked up.
yeah, like how much funds need to be locked up?
Yeah, that's a good question. That's actually the exact collateralization problem that we're trying to learn more about right now. Is that it's hard to tell. So in a Lightning style network, what's happening is that people are constantly paying each other back and forth. So nodes that are in the middle that are being routed over a lot are seeing direct volume, or seeing like payment volume going in both directions. Now, if that money is going in both directions, and if you're able to make it so that the rate that money is flowing in from like east to west is the same as it's flowing from west to east, in that case, you don't actually ever really need to recollateralize your channel, right? And then in that case, the amount of money that you have in your channel just needs to be equal to the largest size of payment that you're willing to allow, right? Because then you could do one payment that pushes all of the collateral from one side of the channel to the other side of the channel, and then that's it. Now the problem is that obviously this doesn't really happen in practice. Like recollateralization is definitely a thing that needs to happen. The cost of recollateralizing and the headache of recollateralizing is a problem, because in many cases payments are unidirectional. So like people are receiving a lot more than they're sending, and so the one of the big criticisms is that Lightning isn't very realistic about how that would work. And I definitely think that there's merit to that. And now the other big criticism is that what is the incentive for the node to actually put up collateral in the first place? So I can sort of to address the first one. I think they're working on ways to make it make like break up payments in ways where they can be done more efficiently so that the network sort of rebalances itself more and more optimistically over time. In our case, that's definitely something that we want to do and we want to buy into. But for now, all we do is we've made it very, very easy to recollateralize. Nodes actually keep their funds in the channel contract itself. And so you can recollateralize a channel or a set of channels as part of an on-chain transaction that happens when a user deposits funds. And the user just pays like a tiny amount more gas, but then, of course, excuse me. Of course, the hub can then reimburse the user for that. The few cents that would take. The other problem is as I mentioned, is like the nodes not having enough incentive to put in collateral. That's definitely an issue. What Lightning assumes is that the amount of money that you'll make from being a node is valuable enough to you that you'd be willing to hold up that collateral somewhere. Basically, what that means is that if you are willing to put a bunch of collateral into the node, you should be making more than a couple of percent APR, whatever you could make on a low risk loan. That is a good question that no one really knows the answer to yet. It's like possible that it works out in one of two ways. Either Lightning, either there's a lot of centralization around Lightning because there's a bunch of people who have very cheap access to collateral, and then they're able to then like store that collateral in nodes and then like earn this return on it, and then they crowd out everybody else from the market. Or Lightning finds other ways to reduce this burden and make it so that like smaller nodes are more incentivized as well. We're not really sure about the answer to that ourselves. That's definitely something that we want to find out more about. I do think it's possible to run a hub profitably and like very profitably if it's done correctly. And I also think it's possible for that collateral itself to be borrowed by the open market on Ethereum, which I don't know if it's something that you could do as easily or in a trust minimized way on Bitcoin. So that's definitely something that I think is like an interesting thing on Ethereum that we are looking into trying is making it so that it's like Uniswap, where you can have the open market provide liquidity for the hub, and then or for any nodes, and then users can then just like transact using that liquidity, and then liquidity providers can earn a return on their on the fees that are generated from the hub directly.
So the hubs could be basically like third parties who are doing it for a profit. And so it'd be like a third party software that companies, instead of starting their own hub, would go to like another company that offers this hub as a service. Is that how that would work in practice, potentially?
In practice, yeah. That's the ultimate goal. Obviously, for now, as a company, it's like better. Like for now, as a company, you can spin up your own hub, and there's value in doing that in the short to middle term, just so that way you have access to it faster. But in the long term, I kind of expect that it's going to be either, career hubs where it's a hub is like a dedicated payment processor or payment provider that whose liquidity or whose collateral may come from the open market because they've sold their debt, basically like quote unquote debt, to the open market that anyone can buy into, and they can people can provide the liquidity for this hub and earn a return on it. Or it becomes easy enough for anyone to spin up a hub or a node themselves, and then people just sort of do it on their computers, right? And then it's just like mining, where it's like you just have a program running on your computer that makes you a few cents every X amount of time.
Yeah, I see those two different scenarios. That makes sense. So in the case of how much like collateral is needed in order for a hub? Like, what is the ratio of collateral needed in a hub in order for the hub to meet a certain transaction volume? How's that calculated?
Yeah, that's a good question. It's at least 1-to-1. So if I have 10,000 users and they all put $30 each, the hub should be in most, yeah, the hub would end up staking at least $300,000. Then it sort of becomes a gas price optimization issue where it's like, if the hub stakes $300,000, but then it's, you know, constantly rebalancing, then the gas price of it constantly rebalancing is probably higher than than the cost of it just staking another $100,000 or $200,000 in order to reduce gas price. Right. So you know, it's probably more than a 1-to-1. It's probably more like somewhere around 1.2, 1.4, 1.5 to 1, and maybe even greater than that.
Wow. So these hubs could actually need access to pretty large amounts of, like, substantial sums of collateral in order to function at a larger scale.
Yeah.
On, let's say, like an application like Twitter or something.
Yeah, but the one thing to keep in mind is that what we're talking about here isn't like the when we say volume, we don't just mean like you can't compare it as apples to apples to like volume on like the Visa network, right? Because I think that's one thing that people keep trying to do is they say, well, Visa processes trillions of dollars of payments. Are you going to put in trillions of dollars into your hubs? I don't think it actually works like that, because when nodes are connected to each other, they will, at least to a certain extent, rebalance themselves. At least to a certain extent, there will be payments going back and forth, and so you are going to get efficiency gains on that over time, which will drop down that ratio for at least some organizations. So I think the like really what the like the 1-to-1 is really against the amount of money that users have put in currently, not the amount of money that users are transacting. Users could transact, maybe a more material way to say this is like, I could put $1 into the hub right now. The hub could stake $1, and I could pay you that dollar. And then so the hub could like pay it to you, and then you could pay that dollar back to me, and then I could pay it to you, and we could just do that back and forth 100 times. And we've done $100 worth of payments. There's $100 worth of technical volume going through the hub, even though there was only $1 ever collateralized. If that makes sense.
Yeah, that makes sense. Yeah. So let's jump over to let's briefly talk about the team at Connext, and tell me a little bit about how many people you have working, and a little bit about the background of the team members, and how much development resources you have access to.
Yeah, absolutely. We're actually a very small team. I'm a big proponent of small teams. I think small teams can get a lot more done with a lot less overhead, just because where we are in the industry right now requires a lot of experimentation, and that requires moving very quickly. So for us, it's been really great to have a very low communication overhead. There's only 5 of us on the core team. There's 3 founders, and then all 3 of us founders are technical. We sort of have our own specializations within the tech. I've been dealing with more of like the protocol dev and protocol research stuff, and then one of my co-founders, Lane, has been working more closely on the client and middle layer stuff, and then Rahul, who is our CTO, is working more on the hub and like overarching architecture things. We also have Hunter, who is our head of growth. He's doing everything that is all of the non-technical parts of Connext, including all of our marketing and all of our growth strategies, things like that, all of the data collection around that. And then in addition to that, he's also doing a bunch of work on our UI. It's a workhorse. It's amazing. And then last but not least, we have one more employee, Bo, who is immensely helpful with DevOps. So he does a lot of the DevOps stuff, but he's also a full stack dev and has been helping out in other places too. Then our community is we probably have, I don't know, like 10 to 20 people who we communicate with extremely regularly and constantly are getting feedback from, who and like some of those people have also like submitted PRs for things that are broken after they've tried things. So there's a certain element of that. We're still working on scaling up our open source contribution. So anybody who has any advice there, we'd really appreciate it. And then the greater Connext community, is a few hundred people who like are pretty invested in the project and pretty interested in seeing the new things that we put out.
And you have the Gitcoin grant, so you guys just got your first grant through Gitcoin. What other projects or what other funding sources have you guys tapped into? Do you have VCs or angel investors, or what type of funding have you guys looked into up until now? And what are you planning? Are you planning on any
additional
funding
stuff?
in the future? Yeah.
Absolutely. We raised from VCs a while back. That was back when we were doing card payments and like trying to integrate. Basically, what we were originally building was a way to integrate like legacy payments, legacy payment networks, and like banks to blockchain, specifically to tokens. Because we wanted, we saw tokens as a really interesting utility tokens as a really interesting way to generate value, and something that like people would need to be able to have easy access to in order to use. Unfortunately, that didn't pan out because that was right when the ICO boom happened, and so obviously the sentiment towards tokens from the existing financial industry was not very good at the time. And we also found that there were deeper issues associated with payments that like no one else was addressing, which is why we started doing what we're doing now. So we raised back then when we were working on that, and our investors have been extremely supportive of the pivot, and are still supporting us. We've also gotten a grant from the Ethereum Foundation, which we got last in the fall, and then this year we're expecting to raise a couple of more or apply for a couple of more grants, and then hopefully maybe within 6 months or so raise another round.
Okay, great. So we've covered everything. There's one other thing that I wanted to briefly touch on more on the tech, going back to the technical side. It was this concept of quote unquote generalized state channels, and the distinction between the generalized state channels and I guess the types of state channels which Connext has so far developed, and how that difference is established. So my understanding is that generalized state channels just refer to being able to interact with a contract on a more general basis. So not just payments, but also other types of transactions and other types of contract, online smart contract based functionality, but not just solely related to sending payments from one user to another. So is that how would you describe that, and is that a good characterization of it?
Sort of. I think there's pretty big limitations, which I think most people, which aren't really covered well in like the way that people think about generalized state channels. The first is that there's limitations to channels in general. Channels are constructs where all parties need to agree in order for an action to be taken. And so there's no need. It's kind of nice because there's no need for a consensus model. There's no need for anything. There's no need for like information propagation or anything like that, where everybody needs to be on the same page in order to take a decision, right? And not having that dramatically simplifies the way that you're able to update state, or the way that you're able to do things. Of course, not having that also means that it's very, very difficult to have a state channel with, hundreds of thousands of people in it, because anytime you did anything, every single person would need to come online and sign that thing in order to prove that they agreed with it. So obviously that's kind of out of the question. So that's one big limitation. The other big limitation is that it's the nothing at stake problem, where it's not really valuable to put something into a channel unless there is value in it being done in a trust minimized way. And the only things where there's value in it being done in a trust minimized way are things where there is some value potentially being transferred. So in other words, are things where it can sort of boil down to a payment or a transaction of some sort, right? So like you wouldn't want to run a game of chess in a state channel where there was no point to winning, right? Like there was no financial outcome. Like you would want to run a game of chess in a payment channel or like in a state channel if winning meant you won some money, but just a normal game of chess, it wouldn't really make sense. And I think that's kind of true for things that go on the Ethereum blockchain in general, where it's like blockchains in general, or like at least Ethereum in general, is really valuable for transfers of value, is really valuable for like conditional or very complex transfers of value or storage of value. But it is all fundamentally related to value. So the way that I would describe generalized state channels is generalizability in state channels is this scale that goes from very, very simple payments where it's just one-to-one payments where both people are online, all the way up to, very, very intensive generalizability where you have some like conditional resolution logic that can be arbitrarily complex, which decides who gets paid what. But it's always on that scale of like someone is being paid to someone is being paid in a much more complex way, if that makes sense.
Yeah, got it. Sounds good. All right. So I've covered everything. We're 45 minutes into it. I appreciate, you're taking your time. I don't want to, take too much of your day for this. And I appreciate you sitting down to come on the podcast and share a little bit about what you're working on with our audience.
Absolutely. Thanks for having me.
Yeah, it's been a pleasure, and it's great having you on. So my guest on the show has been Arjun. Sorry, could you tell me your last name one more time?
Bhuktani.
My guest on the show has been Arjun Bhuktani. It was a pleasure having you, and we look forward to having you on again in the future when you have new announcements to make, and we'll look forward to speaking again soon.
Absolutely. Thanks a lot, Angel.
Thanks for listening to another episode of the Bounty Zero X podcast. Please remember to subscribe to our podcast below. Check out bountyzerox.io, the #1 bounty hunting platform where you can complete work and earn cryptocurrency. Please consult your professional financial investment and tax advisors before making any investment in initial coin offerings. Bounty Zero X does not provide investment or financial advice and does not endorse or recommend investment in any ICOs advertised on the Bounty Zero X podcast or website.